Alright guys, so when looking at a problem like this, right, we have we have actually two problems and one information set. So when looking at a problem like this, it may look a little bit scary, but once we start walking through the questions, it's a little bit easier, alright? So before we even read these questions, we want to analyze this information that it gives us, alright? So it says, and before we even read this information set right here, we have to look at this equation that it gives us, alright? So it says A is equal to 1052 plus 1.08t. All right, so A, it looks like our output, right, our dependent variable. Um, and this 1052 right here, it looks like some sort of initial value right here. And the 1.08, that looks like some sort of constant rate of change, right? T. That's how um, that's going to be our independent variable, right? So the thing that changes, all right? So um, once we sort of figure that out, we can read this information set. All right, so it says the speed of a sound wave in air depends on the air temperature. The formula shows the relationship between A. All right, so we're gonna underline it. A, the speed of the sound wave. Right, so we're gonna have speed of sound wave A in feet per second, and T, the air temperature in degrees Fahrenheit. All right, so it's telling us the if the degrees Fahrenheit changes, that means the speed of the sound wave will change, right? And then 1052 is some sort of default value. All right, so let's look at the questions now. Which of the following expresses the air temperature in terms of speed of a sound wave? All right, so it says which of the following expresses. So it's basically asking us to find the value of t, right? Because it has a bunch of t values right here, right? So it's saying find t in terms of a. All right, that's basically what it's telling us. All right, but it gives us a little bit more of a complicated wording, all right. But when we're solving this problem, it's important not to get caught up in the wording, right? Rewrite if you need to. You can cross out this question and rewrite what the question's asking you, and what it's asking you to do is solve for t, all right. So this is easy. We can just drag this equation back down here, all right. We're going to say a is equal to 1052 plus 1.08t. All right, and all we want to do is just isolate this t right here. So we're going to subtract 1052 on both sides. Minus 1052 is equal to 1.08t. All right, and we're going to isolate this t again, so we're going to divide 1.08 on both sides. You have a minus 1052 divided by 1.08. All right, and that's going to be equal to t, right? Basic algebra right here to solve for our answer, all right? And we're going to see which one of these answer choices matches up with this, all right? So we're going to start with D. 1.08 divided by A plus 1052. Well, it doesn't match our answer, so we're going to cross that out. 1052 minus A over 1.08. Well, that almost matches our answer, but we're just missing this little part right here. So we're going to cross that out as well. A plus 1052 divided by 1.08. Well, in here it's actually minus 1052. So we're going to cross that out. And our answer is A, all right? So we solved this first problem. Now we're going to move on to this next one, all right? And be careful, right? Uh, make sure you're still taking this stuff into account when you're solving this question, right? Once you see this little line right here, you can forget about the information right here, but it's always good to remember what you're doing, all right? So it says, at which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second, all right? So it says speed of a sound wave, right? They're not asking for temperature, they're asking for the sound wave be closest to 1,000 feet. So we can use our little equation that we made back up here, and we just need to plug in 1,000 feet per second for the sound wave, right? A, all right? So that's what they're asking us. Speed of a sound wave closer to 1,000 feet per second. All right, so we just plug in 1,000, so 1,000 minus 1052 over 1.08 is equal to t. All right, and by the way, guys, when you have these two-step equations, right, it's really important not to erase any work, right, because equations that you find in the first problem may be very useful for your second problem, right? So remember all the work that you did. That's why I always encourage you to show your work and just leave it there. Circle some things that are important, all right? So let's solve this equation now. So we have 1,000 minus 1,052. Well, that's negative 52 over 1.08 is equal to t. And then since this is a calculator section right here, we'll have the luxury of a calculator, right? So we can just do on our little calculator negative 52 divided by 1.08, and that's going to give us negative 48. It's going to give us negative 48.148, and then so on is equal to t, all right? So there's no negative 48.148 blah blah blah, right? But it's telling us closest to 1,000 feet per second, and the closest one to this, right, is our answer right here, all right? So we successfully solved questions 9 and 10 that relate to each other given a information set, all right? And the key to really solving these problems is to never forget your work, all right? So always, write down your work and circle the important things, all right? Circle what you think will most heavily affect the next question, right? Because the two questions are definitely related, all right? So if you get one of these questions wrong, you're probably going to get the next question wrong, right? So it's key to really take some time on this first question so you can have a higher probability of getting the next question right, all right? So that's how you solve these two answer set questions, all right? I guess that's what you call them. And definitely you can rewind this video if you found some things confusing. I definitely encourage that. I really hope you guys found this video useful, and I'll see you guys in the next one.